Hello, thanks for tuning in to All This Math. I'm Professor Parker, and on this session, we're going to be talking about solving equations that have fractions in them. Now, let me talk about why I chose this topic for today, because this is the bane of the existence of a lot of students, because a lot of people out there hate fractions. A lot of people out there don't understand how fractions work, and when they see a question like this or a problem like this and like this one, they'll just put their pencil down and just give up right then and there because of this fear of fractions. And I don't know if it's always a fear, but it's definitely a situation where people don't know how to do these problems because they have fractions in them. So what I want to do is I want to show you how to do these problems so that way when you see a problem like this, whether it's on a classwork, a homework, a test, a quiz, whatever, you won't feel intimidated or you won't feel unprepared, and you'll know how to do the problem and you'll be able to get to the right answer. All right, so let's get into this. Number one, we have 3x over 5 is equal to x minus 2 over 4. Now our instructions are to solve. So what that means, we want to solve for the variable. In this case, we have x, but we have x in two different places though. It's not a problem, not an issue. We can still figure this out. So what we're trying to do is we're trying to figure out what number, out of all the numbers in the whole universe, what number can go in the place of x, meaning 3 times that number divided by 5 would be equal to that same number minus 2 divided by 4. And there's specific steps that we can follow to get to that answer. All right? Because we don't want to sit up here and just have to guess. If you don't know the steps, then you'll be limited to just having to guess. And we don't want you to have to guess. We want to give you a set of steps that you can follow every time you see a problem that looks like this, and that will always bring you to the correct answer. All right, so let's take a look at this. So we have one fraction on the left side of the equal sign and another fraction on the other side of the equal sign. So a lot of people don't like fractions. Okay, cool. We can get rid of the fractions. And this is how you do that. This is called a proportion. Whenever you have a fraction set equal to another fraction, that's called a proportion. Right? So what you can do is something called cross multiply. Not cross cancel, but you can cross multiply. Meaning you can multiply this 3x by this 4, and you can multiply this 5 by the x minus 2. All right? So what does that look like though? You're still going to have an equal sign in between. So I can write that like that. 3x times 4. I'm going to just show every step. So 3x times 4, that's going to go on the left side. You could have put it on the right. It doesn't matter though. Just as long as one of these diagonals, the product from one of these diagonals is on one side and the product from the other diagonal is on the other side. That's all that matters. And then we're going to have 5 times x minus 2. Now be careful when you get to this because you need to throw some parentheses in there, right? Because you're not just multiplying 5 by x, you're multiplying 5 by x and the negative 2. So that's what that should look like. And you have to use parentheses because what that means is that means you're going to use the distributive property. And you're going to multiply 5 by everything in this numerator. If you don't use parentheses, that would mean that you're really just multiplying the 5 by the x. And we don't want to do that. All right? So now we have this set up. We have 3x times 4. So now we can do that multiplication. 3x times 4 is 12x. Because 3 times 4 is 12, and x was part of the terms. So we got 12x. Bring your equal sign down. Now, we need to multiply this 5. We need to distribute this 5 into this binomial, these two terms. So we need to distribute this 5 and multiply 5 by both of these terms. So we first do 5 times x, and then we're going to do 5 times negative 2. All right? That's called distributive justice. That's what that is. That's distributive justice. That's when what's supposed to be distributed gets distributed to everybody. A lot of people make the mistake of they commit what's called distributive injustice, where they'll only multiply the 5 by the x. They won't multiply the 5 by the negative 2 also. Right? You got to multiply this outside number by everything inside the parentheses. Everything. All right? Or else you'll get the wrong answer. But I forgot to mention something. Notice how I said, like, a lot of people don't like fractions. That's cool, right? Because we can get rid of the fractions. So when we get to this step, look at how there are no fractions. The fractions are gone. And if you're a person that doesn't like fractions, you don't like to do problems with fractions, that's fine. Just get rid of the fractions. And this is how you do it. In this type of problem, we're cross multiplying. When you got one fraction on the left, one fraction on the right, cross multiply, the fractions automatically disappear. All right, and this is mathematically sound. So now, let's get back to it. Now we're at this step. We got 12x is equal to 5x minus 10. You got a couple things you could do. I'm going to, because I need all the x's on one side of the equal sign. I can't have x's on the left and on the right. I got to get organized. You want to like organize your problem. We got x's all over the place. We can't have it. So what I'm going to do is, I'm going to subtract 5x on the right side, and I'm going to subtract 5x on the left side. Usually I like to transpose, but I didn't want to do that in this problem. I want to do something different. All right? So now, 12x minus 5x is going to leave me with 7x's. I bring my equal sign down. 5x minus 5x, that's nothing. That's 0. And that's what we wanted to happen, because we don't want the 5x on the right-hand side. So now the 5x is gone because I subtracted 5x from it. And as long as I maintain balance, which is what we should have in mathematics, we should always have balance. And we really should have balance in life just in general. But anyway, right? We want to subtract 5x on both sides. Now we have 7x on the left side. But what about this negative 10? We need to bring that down, right? So we got 7x is equal to negative 10, right? And it doesn't matter if I like slide it over a little bit, just as long as it's still on the right side of the equal sign. All right? So now I want to get x by itself. So I need to get rid of the 7. So you ask yourself, what operation is 7 involved in right now? This is 7x, which means 7 times x. So 7 is involved in multiplication. So the opposite of multiplication is division. So that means you need to divide by 7 on the left side, and you also divide by 7 on the right side. 7 divided by 7 is 1, so that becomes 1x. 1x is the same thing as just saying x. So you don't have to write the 1 in front of the x. You can just write x. And then over here, you got negative 10 over 7. Before you rewrite this, you should ask yourself, can you reduce this fraction? We can't. I mean, we could convert it to a mixed number, but we don't need to do that. Unless your teacher specifically wants you to convert to a mixed number, but usually in algebra, we don't deal with mixed numbers. All right? That's at the more fundamental levels. We deal with mixed numbers. So this is a good answer. So we can just say, okay, negative 10 sevenths. And stop right there. All right? Now, I do want to check my work. So let's go back. Let's go back up here. And let's check our work. Because I want us to be in the habit of checking our work. All right, so what that means, everywhere I see an x, and this is going to be ugly, it's going to be kind of messy because that's a fraction. All right, let's just be honest. Like this is a fraction, so I already know from looking at this is going to be kind of messy. So I'm going to write this up here. 3 times negative 10 sevenths over 5. Is that equal to negative 10 sevenths minus 2 over 4? That's the question. Now, 3 times negative 10 sevenths. That's going to be negative 30 sevenths over 5. And then over here, negative 10 sevenths minus 2. In the interest of time, I'm not really going to go into great detail in every step I do with this check. I just want to show you how to check it and make sure that we do it, in fact, have the right answer. And we'll know that we have the right answer if I get the same number on the left side as I do on the right side once I do all these calculations. So negative 10 sevenths minus 2, that's going to be the same thing as negative 14 sevenths. So negative 10 minus 14 is negative 24 sevenths divided by 4, because negative 10 sevenths, and then I need a common denominator, so this negative 2 is going to turn into negative 14 over 7. Negative 10 minus 14 is negative 24. That's where the negative 24 came from. We got negative 24 over 7 over 4. So now over here, I got, let me see, negative 30 over 7 divided by 5 is equal to negative 24 over 7 divided by 4. Now the question is this going to be the same thing? Now when we divide fractions, you usually do the thing that most people call keep, change, flip, right? And we actually end up multiplying these fractions. So negative 30 over 7 times 1/5. And then over here, we got negative 24 over 7 times 1/4, right? So now I can cross cancel the 30 and the 5. That's going to turn into a 1. That's going to turn into a 6. Negative 6 times 1 is negative 6 over the 7 from right there. And then over here I can cross cancel. The 4 divided by 4 is 1. Negative 24 divided by 4 is 6. So then I got negative 6 times 1. That gives me the negative 6. And 7 times 1 is 7. And we good. Negative 6 sevenths is equal to negative 6 sevenths. So we straight. All right. So this was the answer. X equals negative 10 sevenths. Boom. That's how you get that. All right. And always get into the habit of checking your work. Right? No matter how messy you think the problem is going to be, that really wasn't even that bad for real. I thought it was going to be, kind of messy and kind of ugly, but it really wasn't that bad, as bad as I thought it was. But yeah, get into the habit of always checking over your work. All right. Now, let me erase this so I can have room for number 2. All right. Now, number 2 has fractions in it also. Right? Except here, it's a little different. You should look and think. You should look and try to see, okay, how is number 2 different from number 1? Number 2 is different from number 1 because number 1 had, in this equation, 1 fraction on the left side and 1 fraction on the right side. Number 2 has 2 fractions on the left side and 1 fraction on the right side. Because of that, remember this. We cannot just cross multiply like we did in this proportion. We can't do that. We have too many fractions. We can only cross multiply when we have 1 fraction on each side. Okay? But again, this lesson is dedicated to the people that don't like fractions. So since you don't like fractions, I'm going to show you how to get rid of the fractions. But you'll get rid of the fractions in a different way than you did in this problem. All right? In this problem over here, you first, in order to get rid of the fractions, you want to think about what the least common denominator would be of these 3 fractions. What is the least common denominator? All right? That's what we want to think about. So we look at the denominators. You say, I see a 5, I see a 3, and I see a 5. All right? So really, I only got to worry about 5 and 3. I'm going to think about what is the smallest number that 5 and 3 both divide into. It's really the LCM. It's really the least common multiple. But when we're talking about fractions, the LCD is just the least common multiple of denominators. So out of 5 and 3, what's the smallest number that they both divide into? The smallest number is 15, right? Now you might be wondering, like, why it's got to be the smallest number? Because if the number's larger, then that makes our mathematics more complex. And our computation is going to be more complex. And when things are more complex, it's likely that we're more likely to make a mistake. It doesn't mean we will make a mistake, but it's more likely. So we want to keep things easy, keep things as light as possible. All right? So we deal with the smallest number that they go into. Because you could say, well, don't 5 and 3 both go into 30? True, they do. 5 and 3 also go into 45. True, 60. The list goes on. But let's deal with the smallest number. That's why it's called the LCD, not just the CD. The L stands for least. So we know that it's 15, right? So on your paper, what you would do is you draw brackets around the whole equation, right? And then that number 15 is going to get multiplied by each of these fractions. So you want to write the 15 outside. You can write it in the back of the equation. You can write it in the front of the equation. It don't really matter for real. So I usually write mine out here in the back though. So then you got 15 multiplied by 2x over 5, right? So really what I'm doing is I could do this one of 2 ways. I could do 15 times 2x, which gives me 30x, and then I divide that 30x by 5, which gives me 6x. So let me just write 6x right there. Or I could think about it like this. I could basically think about it as like cross-canceling when multiplying 2 fractions. I could do 15 divided by 5, which is going to give me 3, and then take that 3 and multiply by 2x, and I still get 6x. So either way, you could multiply first and then divide, or you could divide first and then multiply. The order doesn't matter. You'll still get the same outcome. We would still get 6x. Just like 15 times negative 1/3. 15 times negative 1/3 is negative 5. All day long. It's always going to be negative 5. So whether I do 15 times negative 1 and get negative 15 and then divide that by 3 to get negative 5, or if I do 15 divided by 3 and I get 5 and I multiply that by negative 1, I still get negative 5. And look what happened. I used to have a fraction right here. Now I don't. I used to have a fraction right here. Now I don't. Now watch what's going to happen with this one. Now, I'm not going to sit up here and multiply 15 by 137. I ain't doing all that. But that's why it's good to know the different tricks, so that you can still arrive at the number or the term that you need, right? So instead of multiplying across and then dividing, I'm going to divide first. 15 divided by 5 is 3. And then I'm going to multiply 3 by 137. So I'm going to do my equal sign. And I'm going to do 3 times 137. So that's 3 times 100 is 300. And then 3 times 30 is 90. So that's 390 plus the 21, because 3 times 7 is 21. So we got, let me see. 390 plus 21, that's going to be 411. 15 divided by 5 was 3. 3 times, 300 plus the 90, 390 plus 21 is 411. Yeah, something's different though. This ain't the answer I got earlier. Yeah, I need to switch something up. Yeah, hold up. Let me change this. I wrote the problem wrong. First step in any question, any work you do, always write the problem correctly. That was not supposed to be a 5 right there. It was supposed to be a 3. So let me just make that change. So if you wrote this down, make the change. This was not supposed to be a 5. This was supposed to be a 3. All right? So I'm going to change that to 3. It doesn't, so that's not going to be a 411. It's not. I knew that looked weird. Because when I did the problem earlier, that number was not familiar to me. But anyway, I'm still going to have an LCD of 15 because it's still the smallest number that both 5 and 3 go into is 15. So I'm still not multiplying 15 times 137. That number's going to be too large. I don't need to do that. I could just do 15 divided by 3, which gives me 5, and then multiply 5 by 137. So 5 times 100 is 500. 30 times 5 is 150. So we thinking, and this is like the mental math, right? 5 times 100, 15 divided by 3 is 5. Then 5 times this number, break it down by place value. You do 5 times 100. That's where I get 500 from. 5 times 30. That's where I get 150 from. 5 times 7, 35. And this is the mental math. So you ever wonder like how people be multiplying big numbers and they don't take no calculator out? They probably are using this method. They're breaking the number down by place value. And you can do the same thing. So then they do 500 plus 150 is 650. 650 plus 35 is 685. All right? So now we got an equation, just like we had in number 1, with no fractions. So if you hate fractions, if you don't dig fractions, that's not your twist, cool, get rid of the fractions. This is how you do it. Pick out your LCD, multiply your LCD by each of the fractions. That will cause the fractions to be eliminated. They will be gone. All right? Now, we're trying to solve for x. First thing I want to do, I want to isolate 6x on the left side, because 6x is on the left side. But it's not by itself because it's got this negative 5 right here. All right? Then after I isolate the 6x, then I'm going to get rid of the 6. And then the x is going to be all alone on the left side of the equation, and I'm going to have the right answer. So first, I want to get rid of negative 5. So I say, well, what's the opposite of subtracting 5? Because in order to get rid of things in equations, we have to do the opposite operation. The opposite of subtracting something is adding something. So I do plus 5. But I also need to add on the other side of the equation. So if I add to negative 5, I need to add to 685. Boom, boom. So the 6x is going to come down, because I'm not doing nothing with that yet. The equal sign is going to come down. And now, what's 685 plus 5? You had $685 and you just got another $5. Now you have $690. So now I got $690. So now I'm getting closer to the end. Now, I got 6x, which means 6 times x. And I'm trying to get rid of 6. So I need to do the opposite operation from what 6 is doing right now. 6 is involved in multiplication. So I need to divide, because division is the opposite of multiplication. So I'm going to divide this 6x by 6. I'm not going to divide this by 6x. A very common mistake. You're not dividing by x because you don't want to get rid of x. You only divide by what you're trying to get rid of. A lot of people will do 6x divided by 6x. Don't do it. You only divide by what you want to get rid of. You don't want to get rid of x. You want x to be there. You want x to be chilling on the left side of the equation. So you don't want to get rid of x. You want the 6 to go. So you got to get rid of that 6. So you divide by 6. Now, 6x divided by 6 on the left side, and then on the right side, because we got to maintain balance, right? We also divide by 6 on the right side. Now, 6 divided by 6 is 1, so that's 1x. 1x is just x, because it's one of them. So we got x, bring your equal sign down. Now, 690 divided by 6. Now we got, again, the mental math. Break it down by place value. I already know that 690 divides, or 6 divides evenly into 690, right? But this is how you do it. Break it down by place value. Kind of like the opposite from what we did to multiply 5 by 137. Ask yourself, how many 6 is going to 600? 100, because 6 times 100 is 600. How many 6 is going to 90? 15, because 6 times 15 is 90. So 100 plus 15 is 115. If you took out a calculator and you did 690 divided by 6, you would also get 115. All right? Now, this is our answer, but let's check our work, though. Let's check our work. So let's go back to the original problem, and let's make sure that what we get on the left side of the equation is equal to what we already had on the right side of the equation. All right? So now, this is our check. So 2 times x. So I'm going to replace the x with 115 because we think that that's our correct answer for x. So we got 2 times 115 divided by 5 minus 1/3 is equal to 137 over 5. All right? So now just do the multiplication. 2 times 115. That's going to be 230. You double the 100 and you double the 15. You get 200, you get 30. 200 plus 30 is 230. So now we got 230 over 5 minus 1/3 is equal to 137 over 5. Yeah, this is going to be a little messy because we have different denominators, right? And you know what else? I made that mistake again. Why do I keep writing 137 over 5? It's not 137 over 5. I'm tripping. It's 137 over 3. Yeah, it's 137 over 3. All right, now, I got a couple options, a couple different directions I could go with this. I could do, I could just eliminate the fractions, just like I did up here. I could just multiply everything by 15. So 15 divided by 5 is 3. 3 times 230 is 690. 15 divided by 3 is 5. 5 times 1 is 5. 15 divided by 3 is 5. Again, 5 times 137. We know that from up here. It's 685. Now the question for us is 690 minus 5 equal to 685? And the answer is yes. So that means that this is correct. We checked it. And x equals 115. So today, like I said, I just wanted to get into solving some equations using fractions because a lot of people have this hatred for fractions. Some people have a fear of fractions. So I just wanted to show you some steps that you can go through when you encounter these equations with fractions in them, right? But you're not going to learn it just from watching this video. You learn it from really getting your hands dirty and really practicing and doing a bunch of problems like this, right? Some people might need to do 5 more problems. Some people might need to do 10. Some people might need to do 20. It is what it is. That's cool. Don't feel bad if you need to do more problems than the next person. Everybody has what I call their magic number of problems that they need to do until they feel proficient and feel confident. And when they're in a position where, until they get to the point where somebody can just put that type of problem in their face and they can just do it, like from muscle memory, basically. All right. So these are equations with fractions in them. There are different ways to approach them. And I hope you learned something. Thanks for tuning in. Continue to send the problems that you would like to have worked out to the All This Math DM, and your problem might make it to this board. Peace.